Welcome to Technically Marv, and technically, some of you have been manually managing your Meteor libraries like some kind of digital peasant. Ill. Look, at some point in time, we all had a folder called Movies with 17 copies of Interstellar in it at varying qualities, a few tints titled Download, and one file just named Final. We don't talk about that file. After the Unraid container overview video, the Meteor stack questions took over the comments. Not all of them, but enough of you asked that I couldn't ignore it, so here it is. The full walkthrough, architecture, folder structure, the R suite with proper quality profiles, a request portal for your family, and Discord notifications so they stop texting you asking if their show is ready yet. One thing before we get into this, like I'll mention again when we get to each app, we're not walking through installation here. If you can find a container in community applications and hit install, you're good. What this guide covers is every configuration decision that actually matters after it's running. If you've never installed a container on Unraid before, this probably isn't your starting point. By the end of this, your storage works for you. Let's build that empire. Before we touch a single container, you need to understand what we're actually building. Because if you get the architecture wrong at the start, everything downstream breaks, and it breaks in ways that are hard to diagnose. Here's the full life cycle of a piece of media in this stack. 1. A user discovers something they want to watch. 2. They submit a request through Seerr. 3. Seerr passes that request to Sonarr or Radarr based on if it was a TV show or movie. 4. Sonarr or Radarr searches your indexers through Prowlarr. 5. It sends a download job to SAB-NZBD or QBitTorrent, my two download clients of choice, but you can configure this with any. 6. The download client grabs the file and drops it in a staging folder. 7. Sonarr or Radarr picks it up, renames it, and moves it to the final library location. 8. Plex detects the new file, pulls metadata, and the show appears in the library. 9. Seerr fires a Discord notification to the user telling them it's ready. 9 steps, and none of them require you after the initial setup. Now, your Unraid environment, a few tins need to be set correctly before containers go in. In Docker settings, make sure custom networks is enabled. We're going to create a dedicated Docker network for all of our media stack containers. This is a non-negotiable. If everything is on the default bridge, container-to-container communication by hostname doesn't work, and you end up hard-coding IP addresses everywhere, which breaks every time a container restarts. We don't do that. Now, if you don't already have a custom Docker network to use, we can open a terminal and create one. I use one called ed_net, but you can name yours whatever you want, like medianet. That's it. Every container in this stack gets assigned to our custom Docker network. In my case, that's ed_net. From that point on, Sonarr can reach SAB-NZB by typing SAB-NZBD as the hostname. Radarr can reach QBitTorrent by typing QBitTorrent, clean, stable, no IP hunting. Now, in my own setup, I have QBitTorrent running through a VPN. So for me, that is the only exception where I actually have to put an IP address in for the various configurations. One more thing on the environment, drives and cache. Your Unraid array is not fast enough for what we're doing. If you're moving large files around during downloads, make sure your cache drive is an NVMe SSD and that your download staging folder lives on the cache, not on the array. We'll get into that in the next section, but keep it in mind. This section is the one most people skip. Don't skip it. Getting this wrong means your seeding breaks, your storage doubles, or your R apps can't rename files. All 3 of these will happen if you don't set this up correctly. The concept you need to understand is atomic moves and hard links. Let me explain both in plain terms. An atomic move is when a file is moved within the same file system, same physical drive or pool, and the operating system completes that move instantly because it's just updating a pointer in the file system. No data is copied, the file doesn't travel, the reference moves. This is why your download client and your final media library need to be on the same Unraid share. If they're on different file systems, the operating system has to copy the file and then delete the original, which is slow, doubles your storage temporarily, and during that window, your seeding client loses track of the file. Hard links are related. A hard link means a single file on disk is accessible from 2 different directory paths simultaneously. Your download client sees the file at one path and continues seeding. Sonarr sees the file at a different path and considers it part of your library. One file, 0 duplication. If you delete the library copy, the seeding copy still exists. If you delete the seeding copy, after the ratio is met, the library copy is completely untouched. For all of this to work, everything has to live under the same top-level Unraid share. This is the structure we're building, and this follows the trash guides convention, which I'll link in the description below. One share called data. Downloads land in data/torrents or data/usenet depending on the client. Sonarr and Radarr hardlink the finished file into data/media. Plex reads from data/media. Your torrent client continues seeding from data/torrents against the same exact underlying file with no duplication. I want to show you that this actually works, not just tell you. So here's the stat command run against the same file in both locations after a fresh import. Same inode number in both places. Links to shows that the operating system knows this single file is referenced from 2 places. That's hard links working. 1 file on disk, 2 paths, 0 wasted storage. Now, how this maps inside Docker containers. This is where people get tripped up and where a lot of guides get it wrong. Not every container needs to access the entire /data share. Each container gets exactly what it needs to do its job and nothing more. Here's the correct breakdown per container. Sonarr and Radarr are the only ones that get the full /data amount because they're the ones performing the actual move from the download location to the media library. They need to see both sides of that operation for the hard link to work. Every other container gets scoped to exactly what it touches. The key thing to notice is that the internal container paths stay consistent across everything. SAB-NZBD thinks it's completed. Usenet downloads live at /data/usenet/complete/tv. Sonarr, looking at the full tree, sees that same path at /data/usenet/complete/tv. The paths agree because they're mapped from the same root on the host. That alignment is what makes the atomic move and the hard link possible. Last 10 in this section, permissions. Your R apps need to be able to rename and move files within that share. On your /data share, set the ownership to match the PUID and the PGID you're using for your containers. The easiest way to do this is to navigate to your /data share and make note of the owner listed. Then you can open a terminal and run ID nobody or the name of whomever was listed as the owner. Unraid defaults to the nobody user. I personally run PUID 99 and PGID 100 across the entire stack, which matches Unraid's defaults. Whatever you choose though, be consistent across every container. Mismatched permissions are the #1 reason Sonarr silently fails to move a file and leaves it sitting in the download folder forever with no obvious error. Structure is done. Let's get into the stack. Like I mentioned at the top, we're not walking through the installation of each of these. That's a search and a click in community applications. What we are going to cover is every configuration decision that actually matters for each one, starting with how they all connect. 5 containers, each with a specific job. Prowlarr manages your indexers, the sources the stack searches when it needs to find a file. It syncs those indexers to Sonarr and Radarr automatically, so you can configure an indexer once in Prowlarr and both apps immediately see it. Sonarr handles TV shows, it tracks your watch list, monitors for new episodes, and triggers downloads. Radarr does the same, but for movies. SAB-NZBD is your Usenet download client. Fast, reliable, great for high bitrate content. QBitTorrent is your torrent client, which stays in the picture primarily for seeding and for content that isn't available on Usenet. Every container in this tag gets assigned to the ed_net network, in my case, or whichever network you created in section 1. An Unraid's Docker template that's under network type, custom, and then the name of your custom Docker network. The volume mappings follow the per container breakdown from section 2. Sonarr and Radarr get the full /data root. The download clients get their respective subfolders. Plex gets /data/media. Once Prowlarr is up, add your indexers. If you're on Usenet, you need at least 1 indexer with NZB access. If you're running torrent trackers, add those as well. Once they're in Prowlarr, go to Settings, Apps, and add Sonarr and Radarr with their API keys, and Prowlarr will push those indexers to both apps automatically. You should never have to configure indexers in Sonarr or Radarr directly. Now, quality profiles. This is where most setups stop being average and start being good. The trash guides exist because the default quality profiles in Sonarr and Radarr are trash. They don't account for HDR format priority, they don't distinguish between Dolby Vision and HDR10, and they'll happily grab a 720p encode when a 2160p Remux is sitting right there. We're going to fix that. Go to trash-guides.info. There are separate guides for Sonarr and Radarr, which are actually important are two tins, custom formats, and a quality profile built on top of those formats. Custom formats or scoring rules. They look at the file name metadata and assign positive or negative scores. Dolby Vision gets a high positive score. Cam rips get a heavily negative score. X265 encodes gets a score based on your preference. The quality profile then sets a minimum score threshold. If a release doesn't hit that threshold, it won't be grabbed. In Sonarr, go to Settings, Custom Formats. You're going to import these one by one. The trash guides walk you through exactly which formats to add. Then go to Settings, Quality Profiles, create a new profile, and set your score cutoffs. For stack targeting HDR10 and Dolby Vision content, your minimum score should be set high enough that standard digital releases don't qualify unless nothing better exists. I know trash guides can feel overwhelming the first time you look at them. There are dozens of custom formats. You don't need all of them. Start with the core HDR formats, the resolution formats, and the release group scores. That covers 90% of what matters. You can tune the rest later once the stack is running. With quality profiles configured, wire up your download clients. In Sonarr, go to Settings, Download Clients, add SAB-NZBD. Host is going to be SAB-NZBD. Add its port and the API key from SAB-NZBD's settings. Add QBitTorrent. Host will be QBitTorrent, but in my case, I use the IP since it runs behind a VPN. Put in the port and you're good. Notice we're using host names in SAB-NZBD and could have for QBitTorrent, not IP addresses. That's the ed_net network doing its job. Inside SAB-NZBD, create two categories, TV and movies. Map each one to its respective subfolder under /data/Usenet. Same thing in QBitTorrent. Create categories that point to /data torrents TV and /data torrents movies. When Sonarr sends a job, it passes the category and the download client drops the file in exactly the right place for the hard link to work. Do the same configuration in Radarr for movie downloads. The acquisition engine is live. Now let's put a human-friendly interface on top of it. Everything we've built so far is invisible to the people in your house. They can't log into Sonarr. They shouldn't be able to. What they need is one place where they can say, hey, I want to watch this, and then get notified when it's ready. That's Seerr and Notifier. Deploy Seerr and assign it to ed_net, our custom Docker network. No /data mount needed here. Seerr doesn't touch files. On first launch, Seerr walks you through a setup wizard. You'll connect using your Plex or Jellyfin account, which pulls in your Plex or Jellyfin libraries. Then you add Sonarr and Radarr as services, same hostname-based connection, same API keys. A few settings worth paying attention to. Under Sonarr settings, set a default quality profile in root folder. This is what Seerr passes along when it creates a new request. Set it to the trash guides profile you just built. Under users, you can set default permissions for people you invite. Family members should have request permissions but not auto-approve. Auto-approve means a request immediately triggers a download without any review. Whether you want this is your call, but know the option exists. Before we get into notifications, let's cover how your family actually reaches Seerr. You have two options, local only, where they hit the server IP and port directly on your home network, or external access so they can request from anywhere. I run mine externally through a Cloudflare tunnel pointed at a domain that I own. But setting that up is its own topic and outside the scope of this guide. If there's enough interest in the comments, I'll cover it separately. For now, either option works. Pick what fits your setup the best. Once Seerr is connected to Plex or Jellyfin, any content that already exists in your library shows up as available in Seerr. Your family can see what you have, request what you don't, and track the status of their requests in real time. It's a clean interface, it works on mobile, and it requires zero technical knowledge to use. Now, notifications. Because it'll just show up eventually is not a good user experience. Seerr handles user-facing notifications natively. Go to Settings, Notifications, add a Discord webhook, and enable it for the events that matter to your users, like Request Approved and Request Available. I personally have them all enabled. When a download finishes and Plex picks it up, Seerr detects the change and fires a Discord notification directly to whoever submitted the request. For this all to work, you need to add their Discord user ID to their account. No third-party tool needed, no extra configuration. Your family members get a ping that their show is ready. That covers the user side, but you also need visibility into the health of the stack itself, and that's where Notifier comes in. Notifier is not for your users, it's for you. Deploy it, assign it to the ed_net, and go to notifier.com to create your account and generate an API key. Inside the Notifier web UI, connect your Sonarr and Radarr instances, then connect a Discord server and designate a channel for admin alerts. From this point forward, if something goes wrong in the stack, Sonarr loses connectivity, Radarr throws an error, a container goes unhealthy, you get a Discord alert before your family starts texting you and asking why nothing is working. 2 notification layers, 2 different audiences. Seerr tells your users when their content is ready. Notifier tells you when something needs your attention. Everything is configured. Let's confirm the whole tin actually works end to end before you call it done. Open Seerr. Submit a request for something you know isn't in your library, a show, a new episode, or a movie that released recently. Submit it. Switch over to Sonarr or Radarr. Within a few seconds, you should see the request appear in the queue. It will show the search running, a release getting evaluated against your quality profile, and a download job being passed to SAB-NZBD or QBitTorrent. Go to your download client. You should see the active download in the queue with the correct category applied. Once it finishes, Sonarr or Radarr picks it up, renames it according to your name and convection, and hard links it into the media library. Plex or Jellyfin detects the new file, and the show or movie appears in your library with full metadata and artwork. And in your Discord channel, the notification fires. If all 5 of those things happened without you intervening, your stack works and you're done. If something broke, the most common failure points are the download client category not matching the path configuration in Sonarr or Radarr, or a permission error preventing the file move. Check Sonarr or Radarr's activity log first. It will tell you exactly what failed and why. And that's it. From a folder on a drive to a fully automated media empire. Requests come in, content goes out, and you didn't touch a single tin after the initial setup. That's the whole point of running your own stack. Nobody's paying for your server. Nobody's telling you what you can run or how to run it. And nobody's going to cancel your favorite show because it wasn't performing well. You built this. It runs because you made it run. That's what makes Homelabs fun, and the feeling is pretty hard to beat. If this was useful, hit that like button. If you have questions or ran into something I didn't cover, drop it in the comments. And let me know what you're running in your Homelab. I always enjoy seeing what people are building. If you want to see more content like this, subscribe. I'm Marv. This has been Technically Marv, and I'll see you in the next one. Peace.